Hey everyone, one of the hot topics this year is AI or artificial intelligence. Maybe you've started to see this popping up in your workplaces, or maybe not yet. I know for myself, this can kind of feel like an intimidating topic to keep up with. We know changes are coming due to AI, but what does it look like? And can someone just give us the scoop on what we need to know as SLPs? Well, yes, that's exactly what this Speech Scope episode is for, so we can have an ethical framework for using AI clinically.
Welcome to Speech Scope, a MedBridge podcast where we conquer challenging topics for the medical SLP. Our aim is to deliver actionable takeaways for clinicians like you through captivating discussions with experts in our field. To receive continuing education credit for this episode and access bonus resources, make sure to check out medbridge.com. Hello, I'm your host, Sarah Baar, a clinical SLP in Michigan with over 15 years of experience. I specialize in adult neurogenic disorders and the life participation approach.
Today, I'm excited to be joined by Dr. Nina Benway, an expert in the area of artificial intelligence, or AI, in speech therapy. We'll be diving deeper into this topic, including recent research and actionable takeaways you can implement right away. Welcome, Nina. We're so glad to have you here. Can you get us started by sharing a little bit more about yourself?
Hi, Sarah. It's so nice to be here. So yes, I'm Dr. Nina Benway. I'm a postdoctoral researcher in electrical and computer engineering at the University of Maryland, College Park. And postdoctoral researchers are people with PhDs who want to get more training in a specific area before heading into traditional PhD-type jobs, like a professor. For me, this meant I wanted to get specialized training in machine learning and speech engineering, so I could really understand clinical AI from all viewpoints, as well as develop my own clinical AI tools. I already had training as a speech scientist, as someone with my Cs who practiced clinically for 6 years, and as someone who studied how to design and run speech therapy clinical trials that scientifically test the important ingredients in speech therapy. So overall, I'm just really interested in how we can improve speech therapy with technology based on what we SLPs think that the technology should be, and not what engineers or large companies think the technology should be.
Wow, fantastic. I'm really glad you're doing what you're doing. I am so impressed that you wanted to go this route, and I want to hear a little bit about what you think about AI, because to me, the area of artificial intelligence, it's exciting, but also maybe kind of intimidating, right? Because it's brand new and it's uncharted territory. So can you tell us what initially attracted you to wanting to learn more about this and how your passion has evolved over time?
Absolutely. Yeah, AI definitely seems like something new, but I think it's less intimidating to think about AI more as a terminology shift. The technology behind AI has been around for a really long time. The ideas behind neural networks that examine human speech and human language are decades old. And how many of us SLPs took a speech science class in grad school where we had to use PROT, like to automatically track F0 or pitch or estimate formants? How many SLPs have used video stroboscopy to look at vocal fold vibration? These are all automated technologies, and that automation has laid the groundwork for what we're now calling AI, or clinical AI. The really impressive things that we can do now with AI are because we have a lot of data collected on the internet about ourselves, our speech, our language, and our society. And now we have enough computing power to examine the data and to do something really cool with the data. There's no doubt that the amount that we are using these technologies and the computing power to do these cool things is a shift for the profession of speech-language pathology.
I'm excited to see where we're going, but I also find it comforting that you're viewing this not as this like entirely new world that's opened up, but just like, okay, this is the next step here, you guys. And it's just the shifting technology, the way we've kind of always been dealing with shifting technology. So I know some of the people listening here today, this might be a completely brand new topic, just thinking about AI in speech therapy. So I thought as we get started, we should just cover some of the basics. Can you tell us, like, what are we talking about when we are talking about AI? And then what are some of the ways that you're starting to see AI being used in a clinical way?
Sure. So artificial intelligence is very generally, it's some sort of computerized system that's designed to make predictions, recommendations, or decisions based on goals set by humans. And when we think about those predictions, recommendations, or decisions in a clinical context, we can think of that as kind of on like two different levels. There's lower level clinical information that can be predicted. So that would be something like individual speech and language measures within an utterance, maybe the percentage of syllables stuttered, or whether a speech sound was correctly articulated. Those are, I think of them as low-level speech measures. Mm-hmm. Then there's also higher-level predictions that take a big picture look about diagnostic or features or severity of a communication impairment that might take into account a battery of speech measures, such as whether a speaker has a language or voice disorder or the severity of their dysarthria. And so we have clinical AI that could theoretically operate at either of those levels. And then we have AI clinicians, which might be a technology that might emulate multiple clinical decisions within an assessment or a treatment session.
Wow. Okay. So let me just stop here. Are you saying we already have, like these AIs are already out there where we could do some of those bigger level diagnostics? Like the AI could just take samples and decide like if it's a language disorder or voice disorder, or that's just more the path we're on?
I think it's definitely correct to say that it's the path we're on. I also think that it's also correct to say that the technology does exist. But there's a difference between what's been developed by engineers in a lab versus what is in practice clinically that's been tested to see if it'll work with real clinical people. So it may be a path we're on. I'm not certain it's the path that we should take to have these systems diagnosing speech and language disorders broadly. But as far as a technological possibility, it certainly is one.
Yes, that helps. And I like I like that you kind of think about technology itself doesn't make it AI. Can you talk about that for a minute?
Yeah, absolutely. So we use technology all the time as speech language pathologists, but there's a difference between clinical technology and clinical AI. So, for example, a lot of my research has been around ultrasound biofeedback for speech production. And so you can imagine that in a pediatric context or in a adult context for someone maybe who has had a stroke and is doing speech rehabilitation. And so the technology there is the ultrasound biofeedback. And so an ultrasound biofeedback display shows the tongue moving in real time. But what it doesn't do is it doesn't make predictions about the speech. And it doesn't make recommendations about what you should do next in treatment. It's just the biofeedback display.
Mm-hmm. Okay.
And, but you also could imagine an ultrasound display that does all of that, but then also predicts the accuracy of the speech sound and makes recommendations for someone how to improve their speech sound next time. And that's what my colleagues at the University of Cincinnati are looking into, if we can design systems that do that. And that would be AI because of the prediction, the recommendation.
Yes. Okay. That makes sense. In talking about using AI in speech therapy, and you just gave us like one great example, we're also going to be talking today about ethical choices and decisions, especially for people who kind of haven't been thinking a lot about AI. That might be just a good place to start. Can you share a little bit about why you think it's important to discuss AI possibilities in the context of making ethical decisions? Like, I'm kind of thinking, what should we be questioning as clinicians?
Oh my God. I think that's such a great question, Sarah, because I think we absolutely should be questioning it all of it.
Okay.
And the first thing to look at is the big picture. And even before you look at the AI tool, think about the clinical practice that the AI tool is trying to replicate. Is that clinical practice evidence-based? Is it best practice? If not, how can an AI tool be any different?
Right.
And then think about what the AI tool is trying to do. And it may be that the tool is trying to do something that's very hard for clinicians to agree on. And it could be that AI could help clinicians with this task. And an example of that in apraxia of speech, we talk about the concept of syllable segregations, which are the pauses between syllables that reflect difficulty with smooth co-articulatory transitions. And when you're listening to speech as a human clinician, it's hard to tell the difference between two syllable segregations, between two pause lengths.
Right.
And two clinicians might not agree on how long a pause was or if the syllable was segregated when they listen to the same speech. But pauses are things that can be objectively measured from a recording with a computer program, something like Pratt. And you can get an exact number, an objective measurement of the pause length in seconds.
Mm-hmm.
So an AI system that learns to measure those pauses between syllables and summarize those pause lengths for clinicians, the syllable segregation, that could be something that AI does really well.
Mm-hmm.
And eventually it could be taught to predict the syllable segregation of words that it's never learned before. And this all works because there's an objective ground truth that the AI is trying to learn to predict. But then you can think of like something totally different that's really hard for clinicians to agree on, where AI might not be able to help. For example, think about severity ratings for child speech, or for example, with adult speakers with dysarthria. Here, the ground truth, the severity rating, is more subjective because severity is not well defined, and it might mean a different thing to different listeners, even if they have similar clinical training. So here, AI will likely have a much tougher job of learning to predict human clinician judgment because humans don't agree on severity.
Yeah.
Mild, moderate, severe categories, they don't map to specific speech measures. They're just general impressions. And so there's no objective ground truth for the AI to learn to predict. And like what's really important is the evidence is showing that it's really hard to do this right in a clinical AI way. It's too squishy a problem, something like severity. So for example, my collaborators Sarah Baar and Julie Liss at Arizona State University have examined how well machine learning algorithms can decide if a speech sample is from someone with dementia or someone who's a healthy control. They looked at 77 different AI algorithms, and they found a bunch of red flags in the systems that wouldn't be there if the systems were trained properly. And as an example, they found that the accuracy of these systems in deciding who has dementia or who has a healthy control, that accuracy got worse when more speakers were used to train these models instead of it getting better like it should. And this highlights that we have a few problems here in training these AI systems. We need enough data, especially for clinical speech. Things like Siri, things like your Google Home, they work so great because we have so much typical adult speech, but we don't have a lot of examples of speech from speakers with motor speech disorders, for example. And so the systems don't perform as well. And then the ground truth about who has dementia or who doesn't, that's not a perfectly reliable thing, right? There's some subjectivity to it. And the problem is, if we use these models with over-optimistic accuracies clinically, the AI would likely be making wrong decisions about the people on your caseload, which is a huge ethical problem.
Right.
And Visar, Julie, and I are part of a team, along with first author Ermin Ning, who have written recommendations for clinical AI developers on how to develop systems that work in actual practice. And so we have these recommendations for the developers, the engineers, and then we have recommendations too for SLPs. And the overall takeaway is to think about AI just like you think about any other evidence-based practice. Is there evidence that a given tool is valid and reliable for clinical use? And is there evidence that it will work without bias in real clinical populations with speakers it has never encountered before?
Fantastic. Wow. That I already am feeling, I'll just admit, like kind of relieved that it's so important that we still use our full knowledge base and critical thinking as SLPs, because of kind of like what you just highlighted, that AI is not always going to get it right. So it's really up to us to make sure we're using it in an evidence-based way. So thank you. That's a really good place to start. I know in the next several years, we will see new ways that AI might be integrated into like the places, departments, or even the individual ways that we work as speech pathologists. And I hope that SLPs are involved in contributing to these decisions. You're obviously doing an amazing job being a model of how to be involved in those decisions. And as people who are kind of just more your normal speech pathologist are involved in those decisions, I think it can be tempting to just say like yes to anything that has an AI label, right? Because it's kind of like the new cool thing. And so do you have some specific recommendations about normal SLPs who are kind of put in the position to give input about how, like a way they could think about evaluating different tools from an ethical or a reliability standpoint? And I thought, we'll kind of cover each of those separately. So let's start just thinking about reliability.
Sure. Yeah. Reliability, Sarah, is so important. And it refers to the stability of measurements across different times and raters. And it indicates like how precise is the AI or how consistent is the AI. And so that's a great place to start when you think about, can I implement this clinically? And the first thing is to think about, we talked about before about the non-AI version of the tool, right? Just like you would evaluate, is that best practice? Think about how reliable is the thing that the AI is trying to automate. If that's not reliable, then you may not have a reliable AI tool. And then you evaluate the clinical AI tool itself. And so generally what you're looking for is consistency. AI tools should be robust to these short-term variations that are not due to the underlying thing that you're trying to measure. So, for example, if a tool is tracking someone's progression through a degenerative motor speech disease, the tool should make the same general conclusion about their speech, whether they were saying words on a Tuesday or a Wednesday, about where they are in this overall progression. Right?
Okay.
Yeah. So what you want is a tool that isn't focused, if that's your goal, the overall progression, you don't want a tool that's focused on small day-to-day or minute-to-minute or word-to-word changes. You want it to look at the big picture, which is what the work of Visar Barish and Julie List does a really good job of doing. And it's probably, I think, safe to say that clinical AI will be the most reliable rating speech or rating language when human clinicians also agree on the ratings, because clinical AI should accurately predict the decisions a human clinician would make. So when human clinicians agree from time to time or between people, it kind of makes sense that those are the situations where AI is best suited to help us in clinical practice.
Yeah, so it's not going to be solving the problems on like the really difficult things that we don't yet agree on.
Right. And that kind of goes back to the example about syllable segregation. Like sometimes we don't agree because it's just hard to think about how long a pause is, but we can measure it. The problem is when we can't measure it, it's a squishy concept. It differs between people, like severity or a diagnostic label, for example. That's where the problem is. Another thing that is kind of tricky is that to understand reliability, the SLPs will need to interpret the clinical AI performance metric, the thing that the engineer reports to say how well this tool worked when they tested it with the speech data that they had. And this involves knowing, as an example, if a clinical AI tool has an acceptable diagnostic specificity or sensitivity. And this is the same general idea of how a clinician knows how often a bedside swallow evaluation catches people who do or do not have dysphagia compared to something like a modified barium swallow study. So when what you're doing is you're comparing the clinical AI tool to the human gold standard.
Yes.
And so it's important to think about it like that too.
It reminds me of just like some of the standardized tests that, we use or develop. You're also kind of thinking about like that type of data to know, like, is this a worthwhile test? So that's helpful to think, okay, we really want to bring those same type of questions and standards when we're evaluating different AI tools.
Yep. And it's a big nebulous question, right? There's a lot of work to be done in this space, but I and my colleague John Preston have a paper in press at Language, Speech, and Hearing Services in Schools. It's a part of the special issue for the ASHA 2023 sessions that received the Changemaker Award. And even though the paper has a pediatric focus, the principles in the paper are global and can be used in adult populations too. And what this paper does is it includes a rubric in the appendix to help SLPs rate the validity, the reliability and the ethical use of a clinical AI tool. The paper's a tutorial, so it walks the clinicians through the questions to ask when they are thinking critically about a clinical AI tool.
Oh, wow. Congratulations. That sounds like an amazing tool. And we'll be sure to stick the link or how people can access that in our handout, because I know I would love to have that at my fingertips too. So, okay, let's think about, so that was kind of all about reliability. And then the next question, similar but different, how specifically do you recommend SLPs evaluate tools more from just an ethical standpoint?
Sure. And so the paper I just mentioned goes, and it's open, it will be published open access, so anyone can read it.
Amazing.
And thanks, yeah. It costs us money to do that, but we very much believe, right, that these things need to be out there.
I will help spread the word about it. So it's worth it. That's
Thank
great.
you. Yes. So the rubric, the tutorial walks you through this, but ultimately comes down to you have to evaluate each clinical AI tool separately for an end user. And that's because your individual clients, your individual patients will have unique characteristics and preferences that relate to ethical use. And so there's two related concepts here. Ethical use involves the adherence of clinical AI to professional standards, things like record keeping, informed consent, things like that. And equitable use emphasizes that all individuals, regardless of their personal attributes, can benefit from the best practices that may include clinical AI. So a big thing here is informed consent. Maybe the first thing through the door is informed consent. Patients might have individual preferences about whether they want their speech uploaded to a server to be analyzed, or their data entered into a system. And so understanding these preferences for your client is part of that conversation. It's important to know how a clinical AI tool may or may not meet HIPAA compliance standards or other laws about data privacy, such as in New York State, there's Education Law 2D for pediatric therapy tools meant to be deployed in schools. For equitable use, this involves examining how the technology aligns with how the linguistic standards in their dialect community, and if the tool will make equally accurate predictions about their speech versus someone else's speech. Mm-hmm. And clinicians can look for efforts that the clinical AI developers have taken to report potential biases in the algorithms, to reduce the biases in the algorithms, and to increase fairness at several stages of the algorithm development. But ultimately, it comes down to we need evidence that shows how these clinical AI tools work in real clinical practice with real clients.
Fantastic. Part of me feels like we're going back to the basics, like so many things that we do. And, I call it person-centered care, where we really can't go into the one-size-fits-all approach, but really this is just like the other ways we make individual decisions for the people we work with. And this is, you really outlined that very nicely. So I know in your research lab, you have been using AI in a way that promotes the principles of motor learning. I would love to hear more about what you're doing. And your research is with kids with speech sound disorders. But as medical SLPs working with adults, we all use the principles of motor learning. Mm-hmm. So I thought it'd be interesting just to hear what your lab's doing and then maybe make some connections to adults with motor speech disorders.
Sure. Yeah, absolutely. So I did my doctoral training with John Preston in the Syracuse University Speech Production Lab, which is a clinical trial lab for childhood speech sound disorders. And what that means is that we scientifically test different versions of therapies with kids learning to improve their speech so we can make conclusions about which ingredients are best for speech therapy. And John's a great scientist and clinician, and he's recently received an award from ASHA for his work. And I think one of his biggest contributions to the field of speech pathology so far has been speech motor chaining. That's a free website that guides clinicians through a session that delivers the principles of motor learning in an adaptive way. So as the learner does better, the practice gets more difficult, and the clinician support fades. It adapts practice variability, feedback type, feedback frequency, practice blocking, like the PMLs like that. And these are motor learning principles that as far as the evidence shows, apply to both child speech therapy and adults with motor speech disorders, because the ultimate goal is not to help learners get better just on sounds and practice words, but like the holy grail, so to speak, is these improvements in unpracticed words. And so we've tested
generalization, right?
Yeah, generalization, absolutely. So we've tested speech motor chaining in 8 or so clinical trials, and we see it help learners improve, whether they're young kids or adults in their 20s. And even though it's not the current focus of our research, John's work has previously shown that chaining, speech motor chaining, plus ultrasound biofeedback has improved speech accuracy for an adult with acquired apraxia of speech following a stroke. So where I come into the story is with the idea that speech motor chaining, the website, can be automated. Right now, the clinician enters their rating of each learner's production attempt into the website with a button click, 1 or 0, or a Y or N for yes or no. And the website calculates which principles of motor learning to change on the next trial to adapt the practice to the learner. But what if we could use automated speech analysis to replace that key press?
Mm-hmm.
And the idea is not to remove the clinician from therapy, but rather extend the clinician's ears into the learner's home so we can help them get enough speech therapy. And I think those principles apply well for children and adults with acquired motor speech disorders, especially following a stroke, when rehabilitation and practice are so important. And so right now we have 3 clinical trials testing various AI clinicians to automate speech therapy practice at home, specifically speech motor chaining, in conjunction with clinician-led speech therapy.
Wow. That's cool. That's that would really be huge because, you know, another one of the principles of motor learning is like getting enough practice, right? And so that would fill a gap, I know, with different adults and kids, like even just making it to speech therapy frequently is difficult. So if we could like put a lot of the practice outside, that sounds like some awesome research.
Yeah, you're spot on. That's exactly our hypothesis and what we're hoping to support the field with clinicians and learners with a tool that can help them get the intensity of practice that they need.
With the topic of AI, are there any education sites you recommend for SLPs to stay up to date on like future tools or trends about AI? I just, because I know you're all into it, I just kind of want to get your insider take. What is your sense of how much things or how quickly things could be changing in the world of speech therapy?
Yeah, that's a great question and a really insightful one. Unfortunately, AI is such a broad concept and it's touching almost every aspect of clinical practice, daily life that we have. There's not any one site that will cover it all. Although I personally believe that AI developers who prioritize clinical practice, who are thinking about SLPs, who are thinking about people with speech or language disorders, are going to be presenting their work at places like the ASHA convention or publishing their research evidence in speech language pathology journals. I truly believe that. Someone who is just engineering systems because they can do cool things with the data, they're not going to be reaching out to clinicians or putting their results in the ASHA convention at these spaces. So in a way, being on the lookout for things like this really fits naturally into the evidence-based practice pipeline that SLPs already have. And another way to think about that, in other words, if a quick Google search doesn't bring you to the information you need to evaluate the suitability of a clinical AI tool for clinical practice, like if you can't find a journal article that talks about how something actually worked in a speech or language therapy session for someone, that's really a red flag about whether you should be using that tool to evaluate or treat people in your clinical practice.
That is a key point. That, like, you summarized that so well. It's not like, oh, just pick any app and just use it. Like, I remember when apps became a thing and people just were like, oh, I'm just going to do any app in therapy. And it's like, no, wait a sec. Like, we need to know, like, what the purpose of this is. And was this studied with people with the type of communication disorder that I'm working with? And you're really saying that same thing. Like, we should easily be able to find those answers. And if you can't easily find it, then that's getting into those red flags you're talking about with the ethical considerations.
Yep, absolutely. So I told you about speech motor chaining and chaining AI. There's another tool for automated speech therapy for children, and it's by a company called Say66. It's called Say Bananas. And they have a page on the website that just lists every research study. that's in every clinical speech language pathology journal or other places, but they put it all in one place for clinicians. So it's things like that you should be looking for.
That's your green flag. Okay.
That's a green flag for sure. Yeah.
Awesome. Okay. So talking maximum impact, what would be your top 3 actionable takeaways for clinicians to put into practice?
Oh, that's a good question. Top 3. So number 1, evaluate the validity, reliability, and ethical use of clinical AI the way you would evaluate any tool. Like you said earlier, like a standardized test. Absolutely. We are SLPs. We already know how to think critically about these tools. It's more about learning the terminology that clinical AI uses. And just based on what I was saying a little bit ago, start by considering tools that are made by teams of developers who understand best practices in speech pathology. We as a profession have worked for a century to work this out, right? So in my opinion, these tools should be building upon the knowledge, the best practices that we have already developed, and then testing them to show how they work in real clinical settings instead of just approaching this problem from a purely engineering standpoint without any knowledge of the profession. And then third, I thought it was so important earlier when you said that the ethical use of clinical AI starts with conversations with clients and parents and families. And just like you would think about how to use any tool ethically, we need to think about that with clinical AI also.
Fantastic. Those are empowering. They feel doable and they feel like great advice. So can we help the audience apply this advice by just talking through a hypothetical but applicable case example?
Sure. So here's a real life example from one of our clinical trials. This research was recently published by me and John Preston in 2024 in the American Journal of Speech Language Pathology. And so in testing this tool, what we decided, the experimental design for the study is that we were going to have our learners work with a clinician, who was me, for 1 full session, and then have 9 more sessions that were mostly AI. And part of what we asked our participants to reflect on at the end was the balance that they thought would be optimal between AI sessions and clinician sessions. And we saw in response after response that families felt the right way to tap into the potential of this technology was for learners to practice at home between sessions with a clinician. And that was really a lot different than the schedule that we first tested, because we had 9 sessions in a row that were mostly AI. So this is what we're testing now. These are the schedules we're testing now, where someone meets with a clinician and then does a few AI sessions between and then meets with the clinician again. And it's that idea of listening to the community and implementing the recommendations that they have about how the tools can be helpful for them is really how to do this ethically.
Mm-hmm.
Another example might be, think about how well a specific tool might work for a particular speaker. And in my research, we saw differences in the accuracy based on the specific speech errors that someone had. So just about everything we do in the lab is around the sound R, because it's the most complex vocal tract configuration. It's the most complex acoustically. It's hard to acquire. And so we focus on that because that's the hardest problem.
So if you get R nailed down, then you feel like, okay, then we can get all the other motor speech things. Is that why you're doing R?
Yeah, typically because we see the kids that speech therapy hasn't helped.
Oh, yeah.
And these are the kids who are maybe in their 17 years old, still with an R distortion, 24, still with an R distortion. Okay. But even within these R errors that everyone had, the system did better when the speaker's articulation was stable, like lead, versus something with a sliding error, like bird, right? So there's even specific types of speech errors it does better with or not, and it depends on person to person. So even though it works for one person, it might not perform across groups of people. Another example is more hypothetical. So everyone has a unique way of speaking that's influenced by some combination of the region they grew up in, the region they live in now, their personal and community identities, and other factors. And you really need to think and ask yourself and find evidence that does this clinical AI tool work equally well for everyone? And we go into this in the publication that I mentioned earlier, the tutorial in language, speech, and hearing services in schools. So the hypothetical example here is that different communities speaking African American English have different linguistic rules for correct morphosyntactic structure in that community. So different rules for what makes a sentence grammatical. And so the question is, would a clinical AI tool that measures language output through grammaticality be able to accurately and equally assess each of these communities? And it shows the importance of understanding both the client in front of you and the description of the AI tool and how it works to determine if that tool would be appropriate for you, your client.
Wow. Those are great examples. I'm curious, like, so how are you spending most of your time when you are doing these studies? Like, are you most of the time like with the clients? Are you like, doing data? Are you coding? I'm curious, like,
Sure.
just what your day-to-day is looking like.
Like Nina personally. Like,
yes,
how does Nina
like
spend her day? Okay.
Like, what does this actually look like to make this happen?
Okay, so it depending on the part of the study that you're in, I have a hand in designing the experimental design. I have a hand in designing the sessions. And for my dissertation, which I described earlier, the one that was published in AJSLP, I was the clinician also giving the treatment. But now that I have so many projects going on, I'm not the one treating. And it's also important that we show that these tools work with a number of clinicians, right?
Yes,
it's
right.
It's not the Nina
not
show.
Always just you. Yeah,
right.
Sure.
So, so what I do now is I do the coding for the AI, and I also personalize the AI algorithm for each speaker. So what we'll do is we'll have someone come into the lab for their session. If it's in person, usually these types of things we do over telepractice. So they'll have their meeting with a clinician. The clinician will let me know that their audio has been recorded, and I run that audio through the machine learning, through the AI tool to update the AI tool's predictions based on their most recent session, with the idea that we want AI that reflects where the learner is right now and reflects the clinician's feedback based on that most recent session. So it really grows through the learner. So
right. It's not static. It's constantly learning the client and adapting.
Yeah. Yep,
Cool.
exactly. So I do that coding. And then I also design systems that can talk to each other, because even if you could code that, you need it to go into our online tool. You need it to be recorded in our science database and all of that stuff. So I do a lot of the data science, the acoustic work, I'm the ML engineer, and then the scientific design. And then once we get our data, I also have a hand in analyzing it, the stats, the writing. I'm living the dream.
Yeah, it sounds like, yes. You have so many talents that you're bringing to the table. Do you feel like you've had a moment so far that you felt like it was like a career breakthrough, or do you view it more as just like little bits like chipping away?
Oh my gosh, the first time. So the clinical AI, this chaining AI, the ears that listen to chaining AI is the tool is called Percept. And I remember the first time that our web developer had hooked Percept up to speech motor chaining and said, go ahead, try it. And I tried it with my speech, and I simulated an R distortion, and my little Bitmoji, because the artificial intelligence clinician is me.
Oh yeah.
In speech motor chaining, right? So that Bitmoji popped up on the screen and said, ooh, not quite. Bring your tongue to your, and I screamed so loud.
We got it. Oh, that is awesome.
That was the big breakthrough moment, but a lot of it is chipping away every day. But as a researcher, it's all about the interesting problems that arise. And the reason that they're interesting is probably because no one has ever faced them before. So thinking about ways to come up with and test solutions for that is definitely one of the most rewarding parts of this career. And then knowing the clinical background to understand what solutions are going to make a difference clinically and be implementable by SLPs. It's like this full circle thing. So
how many and I'll just say years, how many years do you think it like will take? So like, you have like this idea as an SLP of like, okay, this is a problem, or like AI could be really helpful here. And so now you're doing all the back work of developing and doing the research, and like, what type of process is it going to be most of the time for people? Several years?
So
Or is it definitely because, maybe you're going about it like with your PhD, so that might be different. I don't know.
Right. So an anecdote and a funny bit would be I worked on Percept for 2 years, right? I worked with a team of researchers who had collected the audio data to put it all in place. I worked to teach myself the neural networks. At that point in my career, I was completely self-trained. I had taught myself Python and I taught myself PyTorch, and then how to make these networks and test them and make them better. And I, of course, had feedback from so many important people: John Preston at Syracuse, Tara McAllister at NYU, Asif Salikin at Syracuse, Carol S.B. Wilson at the University of Maryland. But it's because it's your dissertation project, it's your apprenticeship in becoming a researcher, you have to do it yourself. So it took me 2 years. And then when I was thinking about the next step, what's the next thing we should test about this system? I had collaborators who were other students at the time they were doc students. They now have their PhDs, but they were in engineering, and they did it all in a week. So, they were able to fly, right? Because the data was in a beautiful condition. And I was telling them, okay, this is what I did, start from here. So I think it's an interesting story because it tells the importance of the team that you have around you. So if you have a multidisciplinary team of clinicians, and I should mention Elaine Hitchcock from MSU, who has also really influenced this work that we've done. And if you have multidisciplinary clinicians, if you have engineers, and everyone knows what their specialty is, and it's you're bringing that team together in like a really synergistic way, it doesn't have to take 2 years. But I will say the biggest time investment is the trialing it to make sure it works with real speakers, and that just the way that these studies are done, they take 4 to 5 years because of how we can't just bring someone in once, right? We bring them in 16 to 20 times. And we know that speech therapy is hard, right? If it were easy, we wouldn't be having these questions. So as far as like when can we start to see these happen, I would argue that a really well-planned clinical trial takes some time. So things should not immediately go from the lab to the clinic. There needs to be that evaluation process.
Yeah. And that just really ties in well with what we've been talking about with making those ethical decisions, that's really the true process that is needed. So, Nina, this has been such an interesting discussion. I know people will want to follow along and see what happens with your work. How can you tell us how we can keep up with what you're doing?
Sure, absolutely. The best way to keep track of what we do clinically with our clinical trials is by following our labs in the Syracuse University Speech Production Lab's Instagram account. And that handle is Speech Production Lab SYR. And that is run by our research SLP, Megan Leese, who is an expert in all things speech therapy.
Thank you so much, Nina, for the insight and the clinical takeaways related to AI in speech therapy.
Thank you. It was so nice to talk with you, Sarah.
Thank you for tuning in to this episode of SpeechScope by MedBridge. Please be sure to subscribe and listen to more of our episodes on Spotify or on your favorite podcast platform and at medbridge.com. If you're listening outside of the MedBridge catalog and would like to access the bonus resources and receive continuing education credit, simply log into your MedBridge account and search for this episode to find the accreditation details. SpeechScope also listens to you. If there's a particular clinician that you'd like to hear from, or if you have a clinical question or challenge that you'd like to see addressed on this podcast, please let us know by leaving a comment on our Instagram posts or by emailing podcasts@medbridge.com.